Life and mathematics are related to each other. If you are good in mathematics, you can solve all types of problems in your life. Hello intellectuals, I am Thakur and you are watching this video in Digital Maths Academy. In the previous video, I have already explained so many questions of trigonometric ratios of multiple angle. If you haven't watched, pause this video, go back and watch all the parts. In the previous parts, I had already explained the formula of multiple angle, right, and some questions. So in this part, I am going to solve so many identities, so not to forget to watch all the videos. So in the first part of identities based on multiple angle, we have the first question here. First question you can see. 1 minus cos 2 theta over sin 2 theta equals to tan theta, right? So first of all, we are going to choose left hand side. Left hand side equals to 1 minus cos 2 theta over sin 2 theta. 1 minus cos 2 theta, right? It has one special formula. 1 minus cos 2 theta equals to 2 sin square theta, and 1 plus cos 2 theta equals to 2 cos square theta. So we can write 1 minus cos 2 theta equals to 2 sin square theta over, and sin 2 theta equals to 2 sin theta dot cos theta. We can cut 2 and 2 very easily. After that, sin square theta gives us sin theta dot sin theta, and over we have here sin theta dot cos theta. Again you can cut sin and sin, and the remaining we have here sin theta over cos theta, that gives us tan theta. That's equal to right hand side, and you can write here proved. We can solve this formula, this question like this also. 1 minus and cos 2 theta in the term of sine, all of you know that in the term of sine we have here 1 minus 2 sin square theta, right, and over 2 sin theta dot cos theta, and when you open the bracket here, that's 1 minus 1 plus 2 sin square theta over 2 sin theta dot cos theta, and here 1 and 1 cancelled, and remaining we have here 2 sin theta dot cos theta over 2 sin theta dot cos theta, isn't it? 2 sin theta dot here 2 sin theta dot, we can write here cos theta, sorry, sin theta, because you have sin square, isn't it? So we can write 2 sin theta or sin theta. Now we can cut sin and sin, 2 and 2, and the remaining we have here sin theta over cos theta, that's equal to tan theta, isn't it? Second identity we have here, sin 2 theta over 1 minus cos 2 theta equals to cot 2 theta, right? So here we are going to choose left hand side. Left hand side equals to sin 2 theta over 1 minus cos 2 theta, and sin 2 theta means 2 sin theta dot cos theta, and 1 minus cos 2 theta, yes, in the previous question I have written 1 minus cos 2 theta equals to 2 sin square theta, right? So that's 2 sin square theta. Then we can cut 2 and 2, and here sin theta dot cos theta over sin theta dot sin theta, and we can cut sin and sin, and remaining we have here cos theta over sin theta, that's equal to cot theta. So we can see there is a cot 2 theta at the right hand side, so that's wrong, so we are going to correct it. There is only theta, right? No cot 2 theta. Sometimes we'll have wrong, there's some incomplete or wrong at the right hand side. So if we are conform, if you know all the formula, then we are right, so not to be worried, whether we are going to have the right answer or not. If you are right, then that's the correct answer. Third identity you have sin 2a minus sin a over 1 minus cos a plus cos 2a equals to tan a. So first of all, we are going to choose left hand side here. So left hand side equals to sine 2a minus sine a over 1 minus cos a plus cos 2a. Have a look here. Sine 2a, we know the formula. So sine 2a gives us 2 sine a dot cos a minus sine a, and here 1 plus cos 2a. Have a look here, right? I am just going to show you here 1 plus cos 2a, right? So 1 plus cos 2a gives us 2 cos square a. Not to forget that. That is 2 cos square a, right? We have here 2 cos square a, then minus cos a. It's not to forget that, okay? Just you can write inside the bracket here. You know, write inside the bracket 1 plus cos 2a equals to 2 cos square a. Not to forget 1 minus cos 2a equals to 2 sin square a, and 1 plus cos 2a equals to 2 cos square a. After that, we have 2 sin a common, you know, so we are going to take 2 sin a common, you know, then we have here cos a minus 1. At the denominator as well, we are going to take 2 cos a common, 2 cos a common, then we have here cos a minus 1. Now 2 we can cut, and cos a minus 1 can also be cancelled, and the remaining we have here sin a over cos a, that gives us tan a. That's equal to right hand side, isn't it? Another identity we have here, tan a plus cot a equals to 2 cos sec 2a, right? So let's choose left hand side here. Left hand side we have tan a plus cot a. Now tan a equals to sin a over cos a, and cot a equals to cos a over sin a, isn't it? Now LCM of sin and cos a, we have here cos a dot sin a, and here cos a, isn't it? So we know the simplification of the ratio, right? So it becomes here sin a into sin a becomes sin square a, and here cos a into cos a becomes cos square a, right? And sin square a plus cos square a equals to 1, and we have here sin a dot cos a means sin a dot cos a, and cos a dot sin a, same thing, right? Just remember one formula, you know, sin 2 equals to 2 sin a dot cos a. Here 2 is missing, isn't it? So what we can do, just we can multiply up and down by 2, here 2 and here also 2. Of course we can do now. Then we have here 2 over 2 sin a dot cos a means sin 2a, and 2 by sin 2a means 2 cosec 2a. So we can write here 2 cosec 2a, and that's equal to right hand side, and that's proved. The fifth identity we have today, 1 plus sec 2a over tan 2a equals to cot a. So we are going to choose left hand side here. Left hand side we have here 1 plus sec 2a over tan 2a, right? So now we don't have formula of sec 2a, so we are going to change sec 2a into cos 2a. So we can write here 1 plus 1 over cos 2a over sin 2a over cos 2a, isn't it? Because tan equals to sin by cos. After that, it's your main line, and here LCM is cos 2a, right? And cos 2a into 1 becomes cos 2a, that's plus 1, and at the denominator we have here sin 2a over cos 2a. And now we can cut cos 2a and cos 2a, yes, very easily, yes, we can cut. And after that we have here 1 plus cos 2a plus 1 and 1 plus cos 2a, same thing. So 1 plus cos 2a we can write 2 cos square a, and at the denominator we have sin 2a, so we can write here 2 sin a dot cos a. So not to forget that here we can write here, we can write 1 plus cos 2a equals to 2 cos square a. After that we can cut 2 and 2, and then we have here cos square a means cos a dot cos a, And here at the denominator we have sin A dot cos A. Again you can cut cos A and cos A. And the remaining we have here cos A over sin A, that gives us cot A. Right? And we have already cot A at the left hand side. So we can write here equals to right hand side. And better will be if you write proved. Isn't it? Next identity we have 1 minus cos 2a over 1 plus cos 2a equals to sec square a minus 1. So let's we choose left hand side. So left hand side we have here 1 minus cos 2a over 1 plus cos 2a. Right? And 1 minus cos 2a, I have explained already in the previous question. 1 minus cos 2 equals to 2 sin square a. And here 1 plus cos 2 equals to 2 cos square a. Isn't it? Here 1 minus cos 2a equals to 2 cos square a. Sorry, 1 minus cos 2 is 1 plus cos 2 is equal to 2 cos square a, and 1 minus cos 2a equals to 2 sin square a. Isn't it? Now we can cut 2 and 2, and after that sin square a by cos square a, we have here tan square a, and tan square a equals to sec square a minus 1, that's equal to right hand side. I disproved. We can change cos 2a in the term of cos a also, right? So cos 2a equals to, I'm just going to show you something here, here 1 minus, we can write cos 2 equals to 2 cos square a minus 1, and here 1 plus, right? Better will be here if you change cos in the term of sin, right? So we can write here 1 minus 2 sin square a, and here cos 2 is equal to 2 cos square a minus 1, isn't it? So when you open the bracket, this one will cancel, here this one and one cancel, and then we can get 2 sin square a over cos square a, then you can get the answer very easily. So thank you for watching this video. If you like such type of educational video, then not to forget to like and share the video, and not to forget to give your precious feedback in the comment box. In the next video, I am going to solve so many identities. So keep watching. Have a good luck.